The Mariana Trench is the deepest point on the Earth's crust. It is formed by the subduction of the Pacific Plate under the Philippine Plate. The extreme depth, temperature, and pressure found there make exploration exceedingly difficult. Before the 20th century, the only way to measure the depth of a body of water was to throw a line over the side of the ship and wait for it to touch the bottom. A rope was knotted every 6 feet, or roughly the distance between a man's hands, with his arm stretched out. This measure came to be known as a knot, and is still used today to measure the speed of ship. It was also called a fathom, a term still used to describe water depth. There were several problems with this method. In order to get an accurate measurement, the rope or line would need to stay absolutely perpendicular to the surface of the water. The slightest movement of the surface vessel could throw off the measurement by dragging the end of the line off its mark. It was even possible for undercurrents, imperceptible by the surface vessel, to carry the line off, and it was also extraordinarily difficult to know exactly when the line hit the bottom. After the advent of sonar during World War II, it became possible for oceanographers to get a relatively accurate picture of the seafloor. Sonar works by emitting a sound and listening for the echo to bounce off of the object you're measuring, in this case the seafloor. The longer the time between the emission and the echo, the farther away the object is. This technology, while far more efficient and accurate, also presented scientists with new challenges. Sound waves travel through water faster than they do through air. They will also travel at different speeds depending on the temperature and salinity of the water. Early soundings did not account for this difference. Further, the first sonar systems were also only capable of recording the depth at a specific point. While it was possible to determine the depth at point A, nearby point B could be at the bottom of A. It wasn't until the advent of the side-scan sonar, in the 1960s, that scientists were able to get an accurate, three-dimensional picture of the ocean floor. Since the late 19th century, a number of vessels from numerous nations have explored the ocean. Of particular interest are those that have studied the deepest place on Earth, the Mariana Trench. The HMS Challenger was a steam-assisted British corvette that had its original cannons replaced with scientific equipment. From 1872 to 1876 it served as the research platform for the Challenger expedition. It was during this expedition that the first soundings of the Mariana Trench were recorded. The Challenger recorded a depth of 26,850 feet. The Challenger also collected samples of the seabed using a bolly rod. The rod used heavy weights to drag down a collection tube. As the weights hit bottom, they triggered a mechanical release mechanism allowing the sample tube to return to the surface. This device presented difficulties as the depth increased. Often when the device would hit bottom, the crew working the line on the ship wouldn't realize until extra line was released. This extra line, typically made of piano wire, would then coil around the device and kink. It was not uncommon for these kinks to cause the line to snap. This problem was eventually solved by attaching the device to several hundred feet of rope, followed by the piano wire. The exact position of the Mariana Trench was located and studied by the British survey ship Challenger 2 in 1951. The Challenger 2 used sonar to measure depth. A depth approximately 36,000 feet was measured using sonar. The location of this sounding has come to be known as the Challenger Deep and is the deepest place on Earth. The Tristan was a Swiss-built bathyscaphe launched in 1953. After serving for some time in the Mediterranean, the Tristan was purchased by the United States Navy in 1957 and refitted with a stronger pressure. A bathyscaphe, unlike a submarine, has no propulsion system. It is also unlike a bathysphere, where instead of being suspended by a cable from a surface ship, they are suspended from their own floats, completely unattached to a surface vessel. Most submersibles use ballast tanks which can be flooded with water and cleared with compressed air to control their depth. Bathyscaphes are designed to operate at great depths, under tremendous amounts of pressure. Such pressure would crush ballast tanks that were filled with air. Instead, gasoline is used, as it is buoyant, incompressible, and readily available. The vessel is loaded down with lead shot to sink it to the bottom. To ascend, the shot is released, and the vessel floats back to the surface. On January 23, 1960, the Tristan board instruments indicated a depth of 37,799 feet. Later this depth was adjusted to 35,814 feet. It had taken the Tristan nearly 5 hours to reach the seabed, and just under 4 hours to return to the surface. The vessel was only able to remain on the bottom for 20 minutes. The next vessel to reach the bottom of the trench was the Japanese remotely operated vehicle, Kariko. The craft recorded a depth of 35,797 feet in February of 1995, and left a plate with its name on the bottom. To date, this is considered to be the most accurate sounding of the trench. Much has been learned in our study thus far of the Mariana Trench. It was initially thought the extreme cold, dark and pressure of the trench would prohibit life. Scientists were thrilled to discover complex organisms, including a type of flounder, at that depth. No human has visited the trench in nearly 50 years. While it's likely that not much has changed there, current technology could make the journey safer and more cost-effective. So little about the deep ocean is known that it's difficult to project what lessons are waiting to be learned.